Hello students, welcome to Math 31, also known as Calculus. Well, to be frank, this class is going to be
your nightmare.
Unless you study and work hard and listen to me attentively, then you'll be just fine. Oh. Then there were two.
Should we leave too? I don't know, I'm not cool enough to know that answer. Staying is definitely the cool thing to do, clearly, because I'm still here. Okay then.
Attention everyone, I'm still the center of attention here. Alright, I have the highest exponent, therefore I have the highest power. Funny joke, right? Just jump right into this like a discontinuous point on a graph. You guys remember Math 20 and Math 30 where you start doing factoring? Well, factoring is really important for calculus and it's going to help us along the way. So I need you to do these two questions, factor them down to their simplest form for me. First of all, x cannot equal anything. That's not how this works. You're factoring, you're trying to make it more simple. And second of all, I don't even know what happened here. This is completely crazy. So the way that you actually do this question is this is a difference of squares. So you get x plus 2 and x minus 2 in the numerator. And this ends up canceling out with the x minus 2 in the denominator. So we can just cross that out and y equals x plus 2. This one should also be fairly simple, which I really don't know what you did in that one. You take out an x, so there's the factoring part. Oopsie. Squared minus 2x minus 24. And after that, you can further by finding what multiplies and adds together. So you end up getting x minus 6 and x plus 4 with an x on the outside. And I noticed that you kept going after. You just keep going. I really don't know what it is. This is the answer right here. Y equals, and that's the whole thing. Now that we've done that factoring and you guys kind of understand it, we're just gonna dive right into the next question like a dolphin to the sea.
What is she talking about?
I'm talking about our next problem here with a dolphin in the sea.
Problem? That sounds like an issue, not an ish me.
So this graph right here represents where a dolphin is jumping in and out of the water. You have our water line here, which is actually our x-axis, and the y-axis is how high our dolphin is jumping. The dolphin here goes up and back in and out of the water. And that's how you know we're doing equations where we're trying to find out where f of x is greater than 0. So we're going to be finding these areas where the dolphin is out of the water. So in the case of the dolphin we were talking about, we're going to be using that when we're determining solutions for when f of x is greater than 0. Our function here is f of x because it's our function in terms of the variable x, and it's greater than 0 on the parts where the dolphin is above the water on our graphs. In order to find when it's greater than 0, we first need to put our restrictions on here where we see that our x has to be between 0 and 8. Because if not, then the dolphin will be flying off into infinity, and the dolphin can't be going into a negative direction. So we have our restrictions here, which determines our sign analysis, which is the next step. Sign analysis is finding where the graph is positive or negative in a regular equation. So we have it going from 0 to 8, which is our restrictions, and we put the zeros from our graph onto the sign analysis, 2, 3, 5, and 6. And that's from a simplified equation. If you have something that's unfactored, then you need to factor it down so you can get the zeros. Okay, so at some point here, you take a number that's smaller or between the two numbers on the ends of your spectrum. If this were infinity, you could pick anything smaller than 2. In this case, I chose 1 because it's smaller than 2 and greater than 0. You put it into the function here, you replace x with 1, and you find out if the number is positive or negative. Since it is a positive number, that's how we know that that part of the graph is greater than 0 between 0 and 2 on our function. You do this with every number between every single one of these intervals. So we have 1, 2.5, 4, 5.5, and 7. Once you replace them, you see positive, negative, positive, negative, positive. If you put it in the graphing calculator, you'll find that it does match up with that, so we know we're on the right track, but you shouldn't have to check the calculator to figure that out. Once we get to the graph, We can draw it by going up and down. The maximums don't really matter. I put them on there so it would seem more realistic, except in this case we have a bionic dolphin just shooting 48 meters into the sky. That's a little bit unfortunate. But anyways, so in the positive areas, we see that it's above the graph, so we know that in here, it's greater than 0. And this all comes in at the end here when we have our statement. So when f of x, our function at the beginning, is greater than 0, it's from 0 to 2 between here, in union with, that's the u. When between 3 and 5, it's also positive, so we put 3 and 5. And then it's from 6 to 8, because that's where our restriction ends, it's still positive. Taylor, are you okay?
Yeah.
Emily, what's your question?
Why are we using these brackets, not like these square ones? These ones are way more fun.
By those fun ones, do you mean square brackets?
Yeah.
All right. So in this case, we see that the function doesn't include 0. And when you're using these round brackets, you're saying that it's not including the number here. So using round brackets around something like 5 to infinity would work because you can't contain infinity. But if we use square brackets around the same thing, you're containing infinity, which is impossible because infinity has no value. And you can even have one side is round and the other one is square, like that. And that way we can see that it include a number with the square brackets, meaning that would have a line under it here, and then we put square brackets. But on the other side, you cannot contain infinity, so you have to use round brackets. So did that answer your question?
Yes, but I still like the other ones better.
Does anybody want to tell me what a tangent is? Emily.
Okay, so one time I was walking in the street, and then I saw a penny, and it made me think of old people, which made me think of my grandma because she makes cookies. And cookies are delicious. Do you like cookies? I love cookies, especially chocolate chip cookies because they remind me of chocolate.
Wow, that is a tangent, but not the kind I'm talking about. Let me just show you on the board. All right, since you guys don't really seem to understand what tangent lines are, I'm just going to show you on the board here. So a tangent line is the point where a line touches only a single point on a function. In order to get that, we have an equation here, but I can't just give you the equation because that wouldn't be teaching you. So I'm going to show you how you get there. You start with a secant line, which is the line that goes right through 2 points on the function. In order to get to the tangent line, the second point that it goes through needs to come and approach the first one. I call the first one x and the second one h because that's what it's taught as and that's what's in the formula here. In order to get to the tangent, once h approaches x, that's how you have your equation of a secant line here, and it turns into a tangent. And then the way you explain how x approaches h is through something called limits, which we're going to further explain in a moment. And the limit is basically when one side of the graph comes towards our x point here, which is basically our 0, because that's where it's supposed to start and where it's supposed to end up. So the equation for the tangent line is the limit as h, right here, approaches our x, which is 0, of the function of the secant line.